Welcome to another math lesson. I'm Mr. Pilarski, and today we're going to be talking about slope-intercept form. That form is y is equal to mx plus b. Up to this point, we've been talking about the slope of a line. We haven't really talked about anything else until this point. We learned how to calculate the slope of a line between 2 points by using the slope formula. We also learned how to find the slope of a graph or of a line on a graph like we're going to see today by identifying 2 points, 2 good points, and counting the slope. Now we're going to use that method today, counting the slope, to help us find the slope on some of these graphs. We're also going to focus on B, which is the y-intercept. So slope-intercept form is important because the slope is easily identified. It's the coefficient on the x, or the rate of change on the x. M is the slope, and B is your y-intercept, hence the word intercept in slope-intercept form. And that means the point where the graph crosses the y-axis. Remember, the vertical axis is your y-axis, or your dependent axis, and the horizontal axis, or the x-axis, is your dependent axis. So let's get into taking a look at some of these graphs in the slope-intercept form. Y is equal to mx plus b. For now, we're going to focus on the slope, or the intercept. So here, I have 4 equations entered. Y is equal to x minus 5. Y sub 2 is equal to x. Y sub 3 is equal to x plus 2. And y sub 4 is equal to x plus 6. So I'm going to graph those for us now. Notice how they come up. The y is equal to, or y sub 1 is equal to x minus 5 is the red graph. The green graph is the y is equal to x. The blue graph is y is equal to x plus 2. And the purplish graph is y is equal to x plus 6. Let's take a look at these numbers here. Let's take a look at where they cross the y-axis at. Remember, this is our y-axis, this is our x-axis. This red line, y is equal to x minus 5, crosses the y-axis at negative 5, which is the ordered pair 0, 5, or 0, negative 5. So the y-intercept here is 0, negative 5. So if we're thinking about the form y is equal to mx plus b, the y-intercept in this case is negative 5. For the green line, y is equal to x, the y-intercept, or the place where this green line crosses the y-axis, is 0, or the ordered pair 0, 0. This is the origin. We learned about this back in Unit 5. This is a direct variation. This is also the parent function. It's called the parent function because it's the most basic linear equation you can have when you have y is equal to x. Everything else is a change of the slope, or a change of the y-intercept. For now, you'll notice we just have x here. The m, or the slope, is the same. We're going to talk about that shortly. Continuing talking about the y-intercept, b, for the blue graph, y is equal to x plus 2. The y-intercept is 2, or the ordered pair 0, 2. And for this purple, I don't have purple, so we're going to use black on it. The purple graph crosses the y-intercept at 6, and that gives the ordered pair 0, 6. If you notice, every ordered pair here has an x value of 0, because that's what the x value is on the y-axis, so it's 0, 6. Commonly, we would refer to this as having a y-intercept of 6, or down here, a y-intercept of negative 5. When we write it out, we should write it out as an ordered pair to indicate its place on the coordinate plane. But anyway, that happens to be the y-intercept, and in each one of these cases, if we were to write this out, or we did write it out actually right here, we could identify that, and you can see in each equation, the y-intercept here is -5. In this case, in the parent function, there is no y-intercept. We could write it in if you wanted to, +0, but there's no need because x plus 0 is x, the additive identity. In this case, the x plus 2, we can see the position. The 2 is in the position where the b is in the general form, y is equal to mx plus b. And finally, in the x plus 6, had the y-intercept of 6, and that 6 is in place of the b there. So let's take a look at how the slope's working out. We saw just there how the y-intercept works out. What I'm going to do here is I'm just going to work with two of the graphs at this point. I'm going to get rid of y is equal to x minus 5 and y is equal to x plus 6. I'll just regraph that. So that leaves us with the green and the blue line. The parent function y is equal to x and y is equal to x plus 2. If we just take a look at the slopes of those lines, if we start with the green line, the parent function y is equal to x. Thinking about y is equal to mx plus b. The y-intercept, let me clean that up. Handwriting got a little sloppy there. If we're thinking about this y-intercept, y is equal to mx plus b. The y-intercept in this case is +0. Let's take a look at the slope. We know when a variable doesn't have a coefficient, the slope is 1, so, or the coefficient is 1. So in this case, m is equal to 1, which means if we go from this point to another point on the line, we could go up 1 and to the right 1, and we should end up on the line, which we do. And here, I'm not real neat at drawing it, but we go up 1 and to the right 1. Our next point would be up 1 and to the right 1. And you can see we're making steps. Up 1 to the right 1. You see I got a little sloppy there. You get the idea. We're making steps, or we're rising up, rise over run. So in this case, the slope, remember, slope is the change in the y's, which I use the Greek letter delta. My students are familiar with that. The Greek letter y, the change in the y's over the change in the x, which gives 1 over 1, which is equal to 1. And we can see that because the coefficient here is 1. Same with the blue line. The only difference in this equation is the y-intercept is 2, or 0, 2, if you write it as an ordered pair. The slope of the blue line, to go from one point to the other one, we know it's 1, so we go up 1 to the right 1. We go, and that would give us our first step. Up 1 to the right 1, that would give us our second step. We could continue this to get more good points, easily identifiable points on the graph. So that's the idea of slope. So let's take a second. I'm going to pause my recording. I'll be back in a second. I'm going to change. I'm going to put some coefficients on here so we can see how the slope affects the way a line looks, or how a line acts. As you noticed, I didn't change the intercepts. The intercepts are still -5, 0, 2, and 6. But I did add slopes. The m value in y is equal to mx plus b. Identifying the slope of these lines is pretty easy. In this case, it's 2. For the red line, the slope is 2. That's the coefficient of the x, or the rate of change on the x. In this case, to enter into this online calculator, I have to put parentheses 2 divided by 3 times x. I do that so we can definitely see the slope is 2/3, and this is for the green line. 2 over 3. You might also write it as more vertical fraction. In this case, it's negative 3/5. So what that means is this has a slope of a line. If we write it as a fraction so we can see the vertical change over the horizontal change, or the change in y over the change in x, this would be 2 over 1. The slope of the green line is 2 over 3. And the slope of the blue line is negative 3 over 5. Now, the whole fraction is negative, negative 3/5. Now, that means we can have a negative numerator or a negative denominator. I'm going to show you how that works. I need to graph these lines, so let's get to that. We'll just be graphing the first three, the red, the green, and the blue for now. Let's see how the graphs act. Now, in this case, we said the slope of the red line was a positive 2, or a 2 over 1. Need to zoom out a little bit. When I zoom out, we can see the y-intercept of the red line. That y-intercept was negative 5. Now, the slope is 2 over 1, which means to go from this point to the next point, I need to go up 2 and to the right 1. And that will give me my next point, or next good point, or integer point on the line. So from this point, I'd go up 2 to the right 1. And that would give me my next point, because the slope of the red line is equal to 2, or to 2 over 1. Moving on to the green line, the slope of the green line is equal to 2/3. Since it's positive, I'm going to go from the y-intercept up 2 and to the right 3. 1, 2, 3. That would give me my good point. Up 2 and to the right 3. I didn't write on the red one, but I could have just easily gone 2, 1, 2, 1. In this case, the slope's 2, 3, so up 2 to the right 3. So then I'd go up 2 and to the right 3. We can see that in the equation. It's the coefficient of the x. For the blue line, I'm going to clear out this green line so you can see the blue line, and I'll clear out the red line too, so we can see the blue line a little bit better, a little bit easier. The slope of the blue line is equal to negative 3/5. Now that negative means from the y-intercept, that's a negative, not an equal sign, that we're going to go down 3 and to the right 5. And that'll give me a good point on the line. So I went down 3 and to the right 5. Go down 3 to the right 5. Now, that could also mean from this point, instead of going down 3 and to the right 5, one of the numbers has to be negative. We could go up 3 and to the left 5. This would be the positive 3, and this would be a negative 5, because we went up and to the left. Left is a negative movement. So that's how it would be negative that way. That's another way to see slope, is in the opposite direction. This has been Mr. Pilarski talking about the slope-intercept form of an equation. Y is equal to mx plus b. That's the slope-intercept form. Where m is your slope and b is your y-intercept. Thanks for watching. Bye-bye.